Let me explain car reverse parking sensor system using ultrasonic sensor, the diagram of which is presented here. You can see the ultrasonic sensor which is connected to the Arduino Uno board, which is further connected to the buzzer. The connection so happens that from the trigger point, Arduino will be able to generate a pulse which is going to be incident on the object. Object which reflects that triggering pulse or the ultrasonic pulse which is received on the echo pin, and it is applied to the Arduino Uno for the further processing. The simple technique is that ultrasonic pulses reflected back to the sensor, which is processed in the Arduino Uno, and duration is found out. Duration of the pulse being sent and received. This duration value is multiplied by a constant value to find out the distance. Distance between the sensor and the object. So based on which the buzzer will be made to work. Like when it is nearer, buzzer will sound high. If it is farther, then buzzer will sound low. Like this, it is indicated about the object, how near or how far it is, so that car can be comfortably without a damage. It can be parked. So let us go to the program part of it. As you saw in the previous display, there was Arduino Uno being connected to an ultrasonic sensor. So based on that, we are going to have our program being designed. As you can see, triggering point, pin, echo pin, and all are given with pin numbers. Then data type for duration is long. Then distance is given a data type of integer, and buzzer is given the pin number of 10. Like that, you have got the pin numbers and the data type being declared. So we are using Arduino Uno board. Arduino Uno basically is a programmable open source microcontroller board. This can be programmed by its own programming language, which is similar to C++, which we are using here. Or else we can use Python to do the programming on Arduino Uno. Uno represents one in Italian language. Now we are going to the setup part of the program. Setup, uh, it runs only one time. What does it do is, it will declare all the inputs and outputs. That means it is going to initialize the input and output pins. As you can see, trigger pin is the output pin, echo pin which is going to receive the echo, which is an input pin obviously, buzzer which is going to be driven by the Arduino board, so that it is naturally an output pin. You have got serial begin. This will adjust the data rate to 9600 bits per second. That is, it will control the exchange of messages at a rate of 9600 bits per second. That is nothing but the baud rate. Now you are entering the void loop. So loop will apply the methods. How many ever times you need to run. That means loop will run the methods under it any number of times. Now you are going to have first one, digital write. So you are going to write low into the trigger pin. So you are sending a low on the trigger pin, followed by that you are generating a 3 microseconds of delay. So you sent a low, and a delay of 3 microsecond, during which triggering pin will be low. Followed by that, you are going to have high on the triggering pin. Then again, you are generating a 11 microseconds. That means a low of 3 microsecond and a high of 11 microsecond is sent on the trigger pin. Now trigger pin is then followed with a low. Now echo pin is red by pulse in. It is red for high. By reading high, we find out the duration at which echo pin could receive a high. Now you are using serial print line, new line character about the echo pin and the duration. These values are displayed on the screen using the method println. Println means printing on the monitor whatever is received on echo pin and the duration thereby taken up for the reflection. Now you have got the duration value, using which applying a formula like a duration into 0.034 divided by 2 times, you are going to find out the distance that again is displayed on the monitor in centimeters. So you sent a pulse on triggering pin and you received the reflection on echo pin. Then that received pulse as well as its duration is displayed on the screen, and the distance is calculated by the formula duration into a constant value given like this. Once the distance is found out, it is displayed on the monitor in units of centimeter. Now we will enter the later part of the program. Now we are going to compare distance with the 10. That means if the distance happens to be less than 10 centimeter, then beep is going to be very continuous on the buzzer. That means it's quite close to the sensor. That is what we understand. If the distance calculated happens to be less than 10, buzzer uh, will make a sound of high and it is continuously will be buzzing. Now, if the distance happens to be more than 10 but less than 50, then again buzzer will beep, but this time little slowly. Then finally, if the distance happens to be more than 50 centimeter but less than 200 centimeter, then again the buzzer is going to beep, but this time further slowly. So there are three cases. If it is less than 10 centimeter, buzzer will be beeping very high. If it is between 10 and 50 centimeter, it will be buzzer will be making sound in an intermediate intervals. If the distance happens to be further more, then buzzer will be taking more interval to create the sound. So like that, you are going to raise the alarm based on whether the object is nearer or farther to the sensor. So finally, you are going to keep the buzzer low if none of the three cases exist. That means if it is more than 200 centimeter, the object is, then buzzer will make absolutely no sound at all. So like this, the program works using the Arduino Uno followed by a ultrasonic sensor to find out the car whether is it nearer to the object or the wall or the block, or is it farther, based on which parking can be done comfortably without any damage. Thank you so much.